So today's lesson will be on mole ratios and chemical reactions. So we have been covering all sorts of items like the scientific notation, molar mass, moles amount, the percent composition, empirical formula. So we've been looking at uh, describing elements and compounds and so forth. Okay, but now we're moving on in this unit to where we're now going to analyze all of this stuff with compounds and reactions. Okay, so again, you have been just calculating the mass of something, just like one compound. But you haven't been really looking at anything else that's affecting it. So today that's what we're doing. So we're going to still continue to calculate things like mass, amount in moles, the number of molecules, but we are going to take into account the reactants and products of a chemical reaction equation, okay? So again, we're taking everything we've covered right from the beginning of this unit where we need to be able to balance an equation, we need to be able to find the molar mass, calculate the amount, etc. Okay. So they have a specific name for this type of stoichiometry. So like in general, this whole unit's called stoichiometry, but when you're actually analyzing, information like mass, moles, and so forth of reactants and products in a chemical reaction equation, they call this gravimetric stoichiometry. Okay, so just more specific term for it. Okay, so we went over the whole idea of mole ratios the other day, so just make sure that you did watch that video with how to deal with mole ratios and so forth, okay? All right, so today what we're going to be doing though, all together now, using those mole ratios is we're going to be presented with a scenario. We have to translate the statements into a skeleton equation and then balance it out. So you write a balanced chemical equation. From there, you need to, jot down things like what stuff do we know, what stuff do we have to find. So kind of like the grasp model. And then when we are now going to convert or compare one substance to another, remember, we can't compare using mass, we can't use grams, we need to be in moles. So we're going to convert our information into moles and make a comparison. Apply the mole ratio. So if we know that something is double the other one, we're going to apply the mole ratio and then get the moles of that new substance and then get it converted to mass if that's required, okay? All right, so these are the steps that you're going to follow today. Yeah, just kind of keep coming back to the checklist here to make sure you're doing everything correctly. Okay, example one, you have to find the mass of hydrogen that is produced when 89 grams of ammonia decomposes into hydrogen and nitrogen. It's ammonia, which is NH3, okay, decomposes into hydrogen and nitrogen. So again, hydrogen is a diatomic, and so is nitrogen. Okay, and I know that these are all gaseous as well. Okay, so ammonia, don't worry if you didn't know that was gaseous, but you know that these are gaseous because we've been practicing those, okay? Okay. All right, so from there, you need to balance this equation. Okay, so the next step is to find the knowns and the unknowns, so the given and required pieces of information. So we have what mass of hydrogen? So we need to find the mass of hydrogen, so I'll just jot that down underneath. Okay, so just a reminder, you need to find this here, okay? So what mass of hydrogen is produced when 89 grams? So we know the mass of ammonia. So when 89 grams of ammonia decomposes into hydrogen and nitrogen. So we don't have any information on nitrogen here, so that's nothing right there, but we have the ammonia for sure, and we need to figure out the mass of hydrogen. Now we need to go through the process of actually finding the mass. So I'm going to show you that there are 3 steps for this process to get to mass that you need to follow. So the first one here is, so again, when we want to compare one compound to another, we can't just compare them, we need to convert them into amount or in moles, okay? So our first step here is we're going to go and change everything to, moles of ammonia. And then our next step will be to convert to moles of hydrogen. Okay, so once you're in moles, you can compare. And then we can get to the mass of hydrogen, which is our goal. Okay, and if we are looking at our formula sheet here, we know to get from mass to moles, we need the molar mass. So we're just going to write a little note in here. So we need to use the molar mass, okay, of NH3 to get to the moles, the amount of ammonia. Okay, and then we need, in here, we're going to use the mole ratio. So I'll explain how to do that. Okay, we're going to use a mole ratio to go from moles of ammonia to moles of hydrogen. And then when we're trying to go back to the mass island, so from moles to mass, again, we need to use molar mass. So we're going to use the molar mass of hydrogen this time. Okay, so this is kind of like a general diagram of what you're going to be doing in order to finish off this question. Okay, so you've already got the balanced chemical equations. You know what's given to you. You know what you have to find. So step one, get everything to moles. Get to moles so you can compare and find the moles of hydrogen. And then we're going to go from there to calculate the mass of hydrogen. Okay, so I'm going to go through and show you how to do the unit analysis method first, and then I will show you how to use the formulas after that, okay? But again, if I know it's kind of 50-50 right now, some of you have been using the unit analysis method, some of you really prefer the formulas, but again, just please look at both methods here. Okay, so we need a couple things here in order to get our calculations going. We need the molar mass of ammonia and hydrogen. So I'm just going to quickly do those over here. Okay, so we are going to go through, and our ultimate goal here is to calculate the mass of hydrogen. Okay, all right, so what do we have to start with? Well, the only information we have here is that there's 89 grams of ammonia to start with. Okay, so we're going to use that number, use the molar mass in order to get to the moles of ammonia. Okay, so here we go. The molar mass here is 17.04 grams per mole. So again, the whole idea with unit analysis is that you want to stack them so that they don't clash together. So you don't want grams and grams at the top. So we're going to flip the molar mass so that we get 17.04 grams at the bottom. And we're going to label everything with what compound we're using it for, okay? All right, so that works there. So now we are here. We're at the amount of ammonia in moles. So now we want to use the mole ratio, and this is what we did the other day. I know we did it so that we were like, okay, we're analyzing ammonia to hydrogen was a 2-to-3 ratio, okay? So we were trying to figure out, okay, how many times greater is that and so forth. So, we went and like divided this by 2, okay, and then got it to here. Okay, and divided the other side by 2, got it to here. So essentially we have a 1 to 1.5 ratio of ammonia to hydrogen, okay? So that's what we were doing, and then we would just take whatever number we got here and multiply by 1.5. So with the unit analysis method, you can actually, instead of doing all of this work here, you can stack them the same as, with the same idea of trying to get rid of the units here. So here, you can think of this as being, 2 moles of ammonia, 3 moles of hydrogen. So if you were to stack them here, so for example, if I just say did that, if I went 2 moles of ammonia and 3 moles of hydrogen. Okay, so if I just because I know that's the ratio, if I just stack them like that, and I'm analyzing here now, see how moles of ammonia here and moles of ammonia, they're right beside each other, and this isn't how this method works. We want to cancel them out. So we have these the wrong way. So you're going to erase this and stack them up again the other way around, okay? So instead of writing ammonia at the top, you're going to write it at the bottom. So you have 2 moles of ammonia and 3 moles of hydrogen. Okay, so now that when we stack this, these two can cancel out. And that's what we want. We want the, the same ones to cancel out. And they can only do that if one's at the top and one's at the bottom. Okay? All right, so that's our mole ratio step right there. Okay, and our last step now is, now that we have moles, so with all of these calculations to here, we have moles of hydrogen. We want to go to the mass of hydrogen. So we're going to do that by using the molar mass of hydrogen. Okay, so again, we're looking here. We have 2.02 grams per mole, and we're trying to figure out which way to stack it here. Okay, so again, if I know we've got a lot of stuff here, so we can start crossing this stuff off, like grams per ammonia, that's gone. Moles of ammonia, that's gone. So really, in the end, we only have one unit left, which is moles of hydrogen. So when we're thinking about how to stack the molar mass up, well, I could put it this way and try it out. So that's my mass of hydrogen to my 1 mole of hydrogen. Okay, and if you look here, oh yeah, that works because the moles of hydrogen, one's at the top, one's at the bottom, and I'll cross out. Okay, like that. So this is why the unit analysis method is, like, if you can get a hang of it, it's quite good because you can do several steps in one calculation, and then you don't have to do multiple calculations and write down multiple steps of work, okay? But anyway, I know it's a little different from what you've seen before, but just kind of keep looking at it, keep trying it, and then hopefully by the end of the unit, by the end of the semester, you'll be here, okay? All right, so again, you know you did this right because all of the units cancel out, and then you're left with grams, which is what the units for mass are, okay? And also it's the mass grams per hydrogen and for hydrogen, which is what we want. All right, so now that comes down to us, like, you can think of this as being over a line as well. You're going to take 89 times 1 times 3 times 2.02 equals, and then divide all of this 17.04 times 2, okay, and get the final answer here. So okay, so I'm going through with my calculator, 89 times 3 times 2.02, and I'm getting, so here, I'll just write what I got so far. So I'm getting 539.34, okay, and that's going to be grams per hydrogen divided by 17.04 times 2. Again, you could do this all in one calculation, just use your brackets and stuff on your calculator, but just if you're having trouble calculating it, you can see what I got. So that's what I got for the top when I multiplied all the numbers. That's what I got on the bottom. So when I take these numbers and divide them, I will get my mass of hydrogen is 15.82557, etc. Okay, and then right now I'm going to check to see how many digits I need here. Okay, so I'm looking up at the top, the initial, so see how it was 89, it was just 2 digits, so I went around to 2 digits here. 16 grams, like that. Okay, all right, and then you'll make a therefore statement. Therefore, the mass of hydrogen, and if you want to be really specific, so it said, what's the mass produced, okay? So the mass of hydrogen produced is 16 grams. Okay, so again, wanted to start with that method just so I could get you more of you convinced to try it, okay? But what I'm going to show you now is just like the step-by-step formula method as well. I just added the label. This is the unit analysis method that we just finished, okay? All right, so we're going to start this question over again. So I just kept our diagram here that we can still use. And now we're going to use the formula method. Okay, so in order to get moles from mass, so we take mass and divide by molar mass. So in this step here of our, I guess our problem solving step, you're going to use the formula N equals mass over molar mass here. Okay, so you're going to use the mass of ammonia, divide by the molar mass to get the moles of ammonia here. Okay, and then from here, the next step here is the mole ratio step. We're going to look at the mole ratio of ammonia to hydrogen, okay, and that's what we'll do in this step. And then in the last step here, we need to go from moles to mass. So we have to get the mass. So we're just going to take this equation and throw the m over there. So that mass, to find mass, you have to take your moles, okay, your amount, and then multiply it by molar mass. Okay, so I'll write that step here. All right, so we're going to, do this in 3 different calculations all the way down the page, okay? So again, I know a lot of you really like this method. It's fine, it's all good, it's all good. I think the future teachers that you'll have in chemistry will use the unit analysis method, and that's why I don't want you to be lost when they're just doing only that method in their lesson and so forth. So that's why I just kind of look at this one, understand it, and then keep trying the unit analysis method, okay? All right, so step 1, it's our first part of our box, I guess, here, okay? We're trying to get to the amount of ammonia. So we can even write that, amount of ammonia. All right, so from there, you want to set up our formula here. So we have, to get the amount of NH3, we need to take the mass and divide by the molar mass. So let's plug those in. So the mass was 89 grams, and the molar mass was 17.04 grams per mole. Okay, so if we calculate that, 89 divided by 17.04, we'll get this big number here. Well, it's a small number, but big decimal number. And then keep it in your calculator, don't clear it out, okay? So I'm just carrying a few extra digits here, and so forth, okay? All right, so, and then that will be moles of ammonia. Okay, so we now know the amount of ammonia that we have. All right, so our first little part of the box is done. So now we're going to the next part, now the mole ratio part. Okay, so again, we need to find now the amount of hydrogen. That's our next goal here. So here, this was the heading for the first part. Okay, step 1, that's what we did. Step 2, now we need to find the amount of hydrogen. Okay, and again, the letters that we'll use are N of H2, okay? So again, the lesson from last day, we were practicing, like if we know the balanced chemical equation here, we know that the amount of ammonia is 2 to 3 hydrogens. So if I have 2 ammonias to start with, it'll break apart and decompose into 3 hydrogens and 1 nitrogen. Okay, so since we know it's a 2 to 3 ratio, if I happen to know the amount of ammonia, I can predict now the amount of hydrogen if you can figure out the ratio here. Okay, so that's what we're going to do now. So we're going to figure out the ratio. So ammonia is to hydrogens. Okay, ammonia was 2, hydrogen was 3. Okay, so, and again, you just take that right from the balanced chemical equation here. All right, so, and again, it's hard to calculate this one because it's a 2 to 3 ratio, and it's not like it's a 1 to 3 where you can just triple it or divide something by 3 and so forth. So what I was telling you guys to do is, remember, just get it so that it's 1. Okay, so the one that you know, get it to 1, and then try to figure out the other one, what it would be. So here I would have to divide by 2, right? So you're going to divide this by 2, and then you get a 3 to 2, 3 over 2, sorry. So then that's the same as saying 1 to 1.5. So for every 1 ammonia that you have, you need 1.5 hydrogen will form. Okay, so every 1 ammonia that you have, 1.5 will form. Every 2 ammonia you have, 3 hydrogen will form. Okay, all right, so now that you know the ratio here, what you did to go from ammonia to hydrogen is you multiply by 1.5. Okay, so for us to calculate now the amount of hydrogen, you're going to take the amount of ammonia, which was right there, 5.223.046, etc. So you still have this on your calculator. Okay, so you're going to take that and you're going to multiply by 1.5. Okay, so when you do that, you will get the moles of hydrogen. Okay, so that ends up being 7.83, etc. Like just again, just keep it in your calculator. On paper, just write down a few digits here. Okay, so now you know the amount of hydrogen. So you went through the first part of the box. You went from mass to moles of ammonia, and then you went from here to here. You went from ammonia amount of moles, and then you went to moles of hydrogen. Okay. All right. We still got one last step. Now that we know the moles of hydrogen, we're going to use this formula here to calculate the mass of hydrogen. Okay, so we'll find the mass. This is our last step, the mass of hydrogen. Okay, so the amount of moles is what we had last time here. Okay, so that's what we had from our previous step. And then we're going to multiply by the molar mass, which I also calculated up here for hydrogen. And it ended up being 2.02 here. Okay, all right, so we'll multiply by that. And we get 15.8, just like we did with the first method. Okay. All right, and then because there's only 2 digits in the initial number that we used, we're just going to keep our answer as the 2 digits as well. All right, and then make a therefore statement. Okay, so the mass of hydrogen is 16 grams. Okay, so that's the formula method. Again, I know it just makes better sense to you guys. You kind of walk through it step by step, so that's fine as well. You can use this method. So now that we've seen it, I just want to again just show you the unit analysis method, and just show you that you're actually doing all of these calculations through the unit analysis method as well. Okay, so just one more unit analysis method here. So again, our goal is to get the mass of hydrogen. So the first step here is to take our mass, 89, and divide by our molar mass. So that's what we did. We took our 89 grams of ammonia, and we divided by the molar mass of ammonia. Okay, but we just wrote it like that. Okay, we're just writing it right beside. All right, and then the next step here, we did we had to find the amount of hydrogen, so we did our mole ratio. Okay, so it was 2 to 3. So, and then with this formula method, we broke it down so it was a 1 to something ratio. So we could just keep it as 2 to 3. So again, I'm going to write the value that I have down here. So I have 2 moles of ammonia compared to 3 moles of hydrogen. And again, I just got that right from the balanced chemical equation. Okay, so there's that step. All right, and then the last step here is the mass step. So what did we do? We ended up multiplying by the molar mass of hydrogen. So we'll do that here. Okay, we're not going to flip the molar mass. We're going to keep it the way it is. And then when you go through, you can check all the units. So we're analyzing the units now, and we're noticing, yep, those cancel out. Those cancel out, so we know they're all in the right spot, and these cancel out. What unit is left? The grams of hydrogen, which is what we want. Okay, so and then from there you would just go through, calculate it all out, and get rounded up 16 grams of hydrogen. Okay, all right, so I guess if you wanted to try the unit analysis method and it was a little bit confusing, now that you've seen the formula method and how it goes step by step, you're calculating out the amount first in this first part of the box, right? Then you use that number using the mole ratio to calculate out the amount of hydrogen. And then from there, the last step of the box here, you calculate out the mass of hydrogen, okay? So that's what you're doing here. Literally, step 1 of the formula method is right here. Okay, step 2 is right here, the mole ratio. Step 3 is that last step to get get to the mass of hydrogen. Okay, so if you're using formulas here, same thing, you should be able to combine all your formulas into one step, okay? But if you prefer to just write it in several steps, then that works as well. But again, I recommend please try to get to the point where you are using this unit analysis method where you're just you're putting all the calculations together, so it's a lot quicker to write out and then a lot quicker to calculate. Okay. Okay, for example 2 here, I'm going to start with the formula method first, and then I'll show the unit analysis next, okay? And I'm also going to do the formula method so that it kind of goes around the box, so it's maybe, you know, you're not going down the page so much, like, so you're over 2 pages of work, okay? All right, so just read through carefully. So freshly exposed surface aluminum quickly reacts with oxygen to form a layer of aluminum oxide. Okay, so this is like a metal oxide forming here. So we have aluminum. So again, right away, start with building your balanced chemical equation here. Okay, so aluminum is a metal, so it's solid state. Oxygen is a diatomic gas. And aluminum oxide is a metal oxide. Metal oxides are solids. Okay, so think of it like rust. Okay, so now that we have our balanced, our skeleton chemical equation, we want to balance it out. Okay, so I'm just going to start with aluminum here and do my guess and check method. So here's aluminum, scanning over at the other aluminum. Well, there's 2 over here, so I'll just write a 2 here. Okay, all right, now I'm going to scan through and look at oxygen here. I have 2 here and I have 3 here. So there's that scenario where you have like an odd and an even number. So I know I have to multiply them both up to a number that they have in common. So they both have a 6 in common, like a common multiple. So I'm going to multiply them both up to 6. So I'm going to change this one and I'll put this one to 2. So that becomes 6. And then I'll put a 3 here. So now I have 6 oxygens and 6 oxygens here, okay? All right, but then when I did that, the aluminum changed. So now aluminum, there's 4 on this side. So now I'm going to adjust this one and change this to 4. Okay, so that's just the guess and check method of balancing equations. So hopefully a lot of you are there. If not, it's okay if you guys want to, you know, write all of the elements and do the tally or the particle, the drawings and so forth, okay? All right, so now that we have those, let's write down the information that we are given. So what mass of oxygen is required? So we need to find the mass of this one, okay? Is required to react completely with aluminum here. So we have the mole amount of aluminum. Okay, we don't have the mass, but we have the moles. Okay, so what we did before is we made that little box method. So we go like this, right? And then we go across, and then we go back up to our unknown, okay? So in our case here, this one was we were trying to go from mass to moles, okay? But we're already there. This is actually already this step here, okay? And then we use our mole ratio, okay, because we had to get to moles of aluminum. Then we get to moles of oxygen, and then we'll get to the mass of oxygen. Okay, so those are the steps that we would use normally. Okay, but our first step of our box here is done, so we're just going to start right there. Okay, all right. So again, this step right here requires the mole ratio step, and this one here, in order to get to mass, we need to take the moles and multiply by the molar mass. Okay, so right now I need the mole ratio, which I can find from the balanced chemical equation, but I need the molar mass of oxygen. So let's just quickly do that over here. So we have that. So oxygen is a diatomic, so 2 times 16, so 32. Okay, so we have our molar mass. All right, so if we're using our formulas here, again, our first step is done. We're already at moles. So now I want to go and get the moles of oxygen. Okay, so how I'm going to do that is I'm going to take the mole ratio here. So let's do that first. So aluminum to oxygen. Let's make a comparison here. So in the balanced chemical equation, aluminum there's 4, oxygen there's 3. Okay, so there's that awkward ratio again that we have to deal with. So we know information about aluminum, so that's the one I'm going to change to 1. Okay, but how do I get there? I need to divide by 4. Okay, so after a while, people get really good at finding the ratio here. They just take the number of the coefficient of the number that you know. So aluminum we know information about, and they just take it and divide it under the coefficient for the one you don't know. Okay, so 3/4. All right, so even like back here, we had ammonia to hydrogen, right? So we had ammonia to hydrogen. So all we did was we took the 2 and divided over 3. So it was a 3/2 in the ratio. All right. Okay. So now that we know it's a 1, 2, and then if you, again, decimals just work better in your brain. So for every 1 aluminum, I need 0.75 of oxygen. Okay, so that's my mole ratio. So I'm going to calculate that right here. So in order to find the moles of oxygen, I'm going to take my moles of aluminum, and I'm just going to multiply by this fraction here. Okay, so 3/4, or if you wanted to use 0.75, that works as well. Okay, so if we take that and we divide it, we get times 3 divided by 4. So we'll get 0.048 moles here. Okay, so we now found the moles of oxygen. All right, and then instead of going down the page, we're going to write the work right here. Okay, so I'll just use a different color here. Okay, so we need to find the mass of oxygen. So to do that, we're going to take the amount that we found back here, and we're going to multiply by the molar mass, which we have above. Okay, and then we get 1.536 grams. Okay, so again, this is another way to use the formula method, kind of make that box and then go around the box with your calculations, so you don't feel like you're going all the way down the page and going over to another page and so forth. Okay, some people find it messy too, so they prefer what we did in example 1 where we listed off one by one. Okay, all right, I'm just going to double check here and round properly. So I have 6.4, see my scientific notation value, so it's just a couple digits, so I'm going to round to 1.5 grams like that. Okay. All right, so that was the formula method going around the box. So now we'll use the unit analysis method, okay? Okay, so now you know that there's always, well, not always, but there's supposed to be 3 steps here. Okay, if you start with mass, you have to go to moles. Then you go to mole ratio, and then you go to the last step here where we get back to mass. So I want you to, just kind of get comfortable doing that, and then now leapfrog from this method to the unit analysis method. So again, our goal is to find the mass of oxygen. Okay, we have this number to start with, 6.4 times 10 to the negative 2 moles. Okay, and that is of aluminum. All right, so again, when we start with the amount of aluminum, we already start in this corner here. So all we're doing is going across the box on this side here. So we need the mole ratio. So the mole ratio here, again, you saw what we're supposed to be doing here. You don't even have to go and do this. You could just use the same numbers that you have in your balanced chemical equation. So again, I always want to write the moles of aluminum on the opposite part of the equation. So if it's already at the top here, I want to write it at the bottom here, like that. Okay, so how many moles of aluminum do I have? Well, look at the balanced chemical equation. I have 4. So comparing that to, what do we need to find? The moles of oxygen. Okay, so that stays at the top, and I have 3 of those. So it's a 3 to 4 here. Okay, all right, so that is that part of the box. Now we're going up on this side of the box, and now we have something to do with the molar mass here. Okay, so again, I'm taking it and I'm looking, and I don't have to flip it because I want to have the grams at the top. So I'm going to take the 32 grams like that over 1 mole of oxygen like that. Okay, all right, so from there you're just going to cancel out. So we have moles of aluminum gone, moles of oxygen, moles of oxygen. So again, I set up all the calculations in this method by looking at where the units are and flipping them if I needed to. But my goal was to try to eliminate any of the same units, and then it leaves me with the unit that I need, which is the mass, grams of oxygen. Okay, all right. So go through, calculate the top, and then divide the bottom. So just at first, I'm going to show the steps here while you're getting comfortable using this method. So I'm going to go 6.04 to the negative 2 times 3 times 32 equals. So at the top, you should, when you hit equals, you should have this on your calculator. Okay. And then at the bottom, it's 4. So divide that by 4 now, and you get the mass of oxygen is 1.536, which is what you had before. Just going to round it. Okay. All right. So now I can do a therefore statement for this question. So therefore, the mass, there's my keyword, mass of oxygen is 1.5 grams. Okay. So again, what will be similar with both methods is it's good to lay out this plan here, but even after you get really comfortable, you don't need to draw this box and you don't have to anymore. You do need to, calculate your molar mass somewhere, so just kind of do it on the side. But then if you're using the formula method, try writing them along the sides of each side of the box, okay? But if you prefer to go down the page, like example 1, that's fine. And then you get the unit analysis method. Hopefully you're seeing here, like this would have been the first part of the box. This is the second part of the box. That's the third part of the box, okay? But it's all together in one calculation, so it's nice and clean, and you get to your final answer really quick. All right, so hopefully you're starting to get the hang of it. It's the 3 steps, okay? And then sometimes, though, it might give you the answer already, so you can skip one of the steps here. All right, so let's go and try the next example. In this example, again, I'm going to start with the formulas and method, and then I'll show you the unit analysis method as well. All right, so let's get from our description to a skeleton equation first. Okay, so let's go through here and balance this chemical equation out. All right, so now that we have it balanced, let's go through and write down the things that are given to us. Okay, what mass of iron 3 oxide is required to produce 100 grams of iron? But in this case here, we're going to have to go the opposite direction. In that case, we're going to go across this way and then get to mass that way. So our box is going to go in the opposite direction, and that's okay too. All right, so let's start with putting our plan together if we're going to use the formula method. So we know that you need to go from mass to moles, right? We can't compare masses. So we have to get to moles of iron, and then we have to convert the moles of iron to the moles of iron 3 oxide. Okay, once we get to the moles of iron 3 oxide, we can get to the mass. Okay, so again, in order to do this, we need to use the molar mass from mass to moles here. So we need the molar mass. And we're going to take the mass and divide by the molar mass. Here we're going to use the mole ratio. Okay, and then the last step here, in order to go back to mass, we're going to take the amount in moles multiplied by the molar mass. Okay, so that means we will need the molar mass of iron and the molar mass of iron 3 oxide. So we have those numbers ready to go, and so now we can go through and calculate. So again, we're going to use the formula method here. So we're going to squeeze these in here. So step 1, that's this step here. So step 1, I'm going to find the moles of iron. Okay, so to do that, I'm going to take the mass of iron, which is 100 grams, and I'm going to divide by the molar mass, which is 55.85. Okay, so I'm just realizing I did that wrong here. So that should be 159.70. Okay, just 70 like that. Okay, all right, so that's the molar mass for that one. So if I take those and divide them, Okay, so I'll get to this value here. So again, I want you to just keep that number in your calculator, don't erase it out. Okay, but I'll just jot down what's on my calculator here. And that's moles of iron. Okay, all right, so that's step one. Here's step two. We'll go to a different color here. Okay, so step two. This is step two. Okay, so step two, I need to find the moles of iron 3 oxide. So in order to do that, I need the mole ratio. So the one I know is iron. The one I need to find is iron 3 oxide. Okay, so now we're looking at our balanced chemical equation here, and iron was 2, and the iron 3 oxide was 1. So hopefully you're understanding now that you have to calculate the molar mass correctly. You have to have a balanced chemical equation correct, because we're using both of these in order to get to our final answer, and it's a lot of different calculations here, so everything's going to be completely wrong if you aren't being careful in those first initial steps. Okay, all right, so iron to iron 3 oxide is a 2-to-1 ratio, so that means as we go this way, what's happening here is we're going to take, oops, no, we're not going that way, we're going this way. We're going from iron to iron 3 oxide. So if for every 2 irons I have 1 iron 3 oxide. So what's happening here is I'm dividing by 2. Okay, I'm going to cut the moles in half here. So let's just do that right now. So to get the amount of iron 3 oxide, I'm going to take the amount from the previous part of the question that I just did, and I'm going to divide by 2. So again, you already have this number in your calculator, so just hit divide 2, and you will get 2. This number here. And again, just keep it in your calculator. Don't hit clear. Okay, so that's the amount of iron 3 oxide. So we have our last step now. Okay, this is step 3. So now we have to calculate the mass of iron 3 oxide. So what we're going to do here is we're going to use the formula. So we're going to take the moles of iron 3 oxide and the molar mass and find the mass. So I'm going to take my 0.89525, and if I can squeeze in all those other numbers I would, but run that space here. And I multiply by molar mass. Okay, and then calculate that out. And I'll get 149.9722 grams of iron 3 oxide. And I'm just double checking here for the units or how many digits. So see how the initial one was 100.0, so I had 4. So I'm going to round this to 1, 2, 3, and then one more digit, the 9. Oh, okay, so I got to round that up to 150.0 grams, like that. Okay, I'll write the therefore statement after I do the other method, but that's what you need to do. 1, 2, 3 calculations. Okay, so going around the box kind of keeps it neater, organized, I guess. But if you prefer to go down the page, that's fine as well. So again, this was method 1, 2, 3. Okay, go from mass to moles of iron 3 oxide, and then to the mass of iron 3 oxide. All right, so that's the formula method. Okay, so let's try the unit analysis method. Okay, so our goal here is to get to the mass of iron 3 oxide. So what do we have to start off with? Well, we have 100 grams of iron. So let's write that in. Okay, so that's step 1. So in order to get from mass to mole island, we need to use molar mass. So how are we going to use it? Well, we're going to flip the molar mass of iron. Okay, so I know it's grams per mole normally, but we're going to flip it to the mole in the air and then mass at the bottom, okay, because then these two will cancel out. All right, so that's that first step like that takes care of the first side of the box. All right, the next step here is the mole ratio. So again, we don't want moles of iron being at the same level here, so we're going to put that at the bottom. So what are we trying to find? We're trying to find the moles of iron 2 oxide. Okay, so the one that you don't know, put it at the top. The one that you do know, put it at the bottom. Okay, look at your balanced chemical equation. Iron is 2, iron 3 oxide is 1. So it's a 1 to 2 ratio. All right, that's that part of the box. Last step here, molar mass of the iron 3 oxide. That one you don't flip. Hopefully now that you've seen a few examples, you're starting to see the pattern here. Okay, so that's iron 3 oxide over 1 mole of iron 3 oxide. Okay, all right, so then you use your unit analysis. Look at all the units. Are they canceling out? Yep. Those ones are canceling out. Yes. Those are canceling out. And then I need mass, so do I have grams left? Yes. So that's how we use this method, and double check that we put everything correctly where we need to. And so that way you don't even have to memorize the formula. You're just using your units and rearranging the equation. So you know to divide here, you know to multiply here, and you know which way to put the mole ratio. Okay, so let's calculate that out. You should be getting, so I'm taking my 100 and multiplying it by, so I don't need to multiply the ones here, but I'm going to multiply by 159.70. Okay, then I get 1,500, 970, and then I can divide by all the stuff at the bottom, so 55, and I'm just putting it all in brackets here. Okay, so then you should end up with the same mass as the other method, but yeah, so you end up with this mass here. $142.97, and now that I double check the calculation for this one, I'm realizing I wrote this one incorrectly off the calculator. So I'm just going to fix this right now and write 142. Okay, so I double checked the calculation. It should have been 142. Okay, all right, so, and then when that rounds up, it's 143 grams, like that. Okay, so now we're going to make our final statement here. Okay, so remember the key words and your units and the value and so forth. Okay, so therefore the mass of iron 3 oxide is 143 grams. Okay, so again, this was the unit analysis method. Okay, we're not memorizing any formulas. We're just stacking everything and trying to eliminate any extra units that we don't need, so we get to the units that we do need, which is grams of iron 3 oxide. Okay. Otherwise, if you want to use the formula method here, that works well. You can try actually going around the box and writing your work around the box, but again, you don't have to. Just whatever will get you to the answer. But again, if you don't like writing all of these calculations out, you can use the unit analysis method. I've seen other mutations of work as well. As long as you're showing me some work, you're not rounding early within your calculations, and you're getting to your final answer with the correct units, go for it. That's great. Okay. All right. So just trying to show lots of examples in this lesson because I'd say it's probably the trickiest part of Chemistry 11. Okay. So this is where if you can do this, you're fantastic. Okay. But if you can't, just work at it, practice, and you will get there. So a couple more examples left. So if you feel pretty confident and you kind of get what you need to do, you can go and try the checkpoint. Otherwise, just kind of keep looking at all these different examples. It's the same idea that you're making a box and going through 3 different calculations from, going from a mass to you end up at another mass for the other substance, okay? All right. So sometimes I'll give you a question where I've already given you the balanced chemical equations, so then that takes that stress out, but hopefully you are awesome at balancing chemical equations, okay? All right, so we have an astronaut exhales carbon dioxide, and the mass of lithium hydroxide required to react with this mass of carbon dioxide is here, okay? So we're taking our carbon dioxide and reacting it with the lithium hydroxide and making these products here. All right, so we know, okay, the mass of carbon dioxide. Okay, what else do we know? Okay, that's it. We have the balanced chemical equation, and then we need the to find the mass of lithium hydroxide. Okay, so let's go through our steps here. Okay, so step one. So we're going to need the molar mass of carbon dioxide, mole ratio, and then back to mass of lithium hydroxide. So again, we cannot, if we have the mass of something, we can't compare it to something completely different. So that's why we have to go to moles. And then once we find the moles, we can use our balanced chemical equation to find the moles of the other one. And then we can go to mass. Okay? All right, so hopefully without looking at the notes, you have the steps kind of down now. All right, so in order for us to go through all these steps, I need the molar mass of these substances here. So I'm going to do that right now. Okay, again, I'm going to use the formula method here. I know I was going around the box and so forth, so what I'll do here is some of you might like to write them all out, so I'll just do them in steps. Nice and neat down the page, okay? All right, so here are the three calculations that we're going to do here. Okay, so again, here's our plan to go from mass of carbon dioxide to moles of carbon dioxide. You need to use this formula here. Okay, then you use the mole ratio in this step here. And then you need to find the mass by taking the amount times the molar mass. Okay, so and I went ahead and I calculated out the molar masses on each side here. Okay, so step one, I need to find the amount of carbon dioxide. Okay, so right now I have the mass of carbon dioxide. All right, so in order to find the amount of carbon dioxide, I'm going to take the mass and divide by the molar mass. Okay, so, whoops, that's positive 2. And then hopefully you are now confident at entering scientific notation values into your calculator. Okay, all right, so I take those two. And calculate out the amount of carbon dioxide here. And just keep it in your calculator. I'm just going to write some of the digits out here. Okay, so that's the amount of carbon dioxide. All right, so step 2, now we're going to do the mole ratio here. Okay, so again, we're going to use the mole ratio in order to find the amount of lithium hydroxide. Okay, so in order to find the amount of lithium hydroxide, I need to do the mole ratio. So I know information about carbon dioxide. I need to find information about lithium hydroxide. Okay, so looking at the balanced chemical equation up here, it's a 1-to-2 ratio. So 1-to-2 ratio. Okay, and already I'm at 1 for the one I know, so that's good. So what am I noticing? So for every 1 carbon dioxide, I need 2 lithium hydroxides in order to get this reaction to go. So I need to multiply by 2. Okay, so what I'm going to do in order to find my amount of lithium hydroxide in moles here, I'm going to take the amount of carbon dioxide that I had in step 1 here, and I'm going to multiply by 2. Okay, so if I do that, I will get this number here. Again, just keep it in your calculator. The more digits you use in your calculations, the better. Okay. And I'm going to go up here now. Step 3. All right, so the last step here is to find the mass of lithium hydroxide. Okay, so I'm going to use M of lithium hydroxide like that. And again, the formula is to take the amount multiplied by the molar mass. So the amount here from the previous part of the question here that I did, step 2, was a number like this, times the molar mass, which I found up there, 2395. Okay, multiply that with the number that's still in your calculator, and you will get 957, 78, 232, etc. in grams. And then I'm looking back at my original question here, 8, like in the scientific notation, the starting value 8.80, so that's 3 digits. So I want to keep 3 digits here. So let's round up to a nice whole number here, 958 grams. Okay, and I'll do my therefore statement in a sec. So again, step 1, we had a mass of carbon dioxide. I can't use my mole ratio using mass values to find the mass of lithium hydroxide. I have to convert to moles first. When I get it to moles, that's when I can use this mole ratio and go, oh, it's a 1:2 ratio. Okay, so I'll just double it. Okay, then you get the lithium hydroxide, and then you go up and you find your mass by multiplying by molar mass. All right, so there's the formula method. Really quick. For the other group of people that want to learn the unit analysis method. Okay, so again, your goal is to find the mass of lithium hydroxide. You have this number to start with, which is the mass of carbon dioxide. Okay, so from there, you know that you have to go from mass to moles island using molar mass. So when you're going to use the molar mass, you know that you have to take the molar mass and you flip it. So what was it here? 44.01. Okay, so that's step 1. Now we have to use the mole ratio. Okay, so again, I'm always going to put the one I already know at the bottom. Okay, because we want to cancel it out with that one there. So and then the one that you don't know, it goes at the top, which is the lithium hydroxide. And now you're going to check your balanced chemical equation, and you're going to find, oh, it's a 1:2 ratio, 1 carbon dioxide to 2 lithium hydroxides. Okay, so that's the step 2 of the box. Now the last part of the box, we want to get to mass, so we're going to multiply by the molar mass, okay, of lithium hydroxide. And I always write the units out in detail, so moles of lithium hydroxide, moles of carbon dioxide, so that when you're actually going through and slashing things out, you know you're canceling out the right things, everything's the right way in the formula, then you know you can calculate your values. Okay? All right, and I'm just going to double check this by actually calculating it out again to make sure I did the other one right. All right, and I do get the same number, 958. All right, so let's do a therefore statement. Therefore, the mass of, so this would have been the mass of lithium hydroxide. So the mass of lithium hydroxide is 958 grams. Last one. So again, please practice lots of these before just moving on to the next topic. Again, sometimes people say that this isn't actually too bad. It's okay. Others do struggle with the gravimetric stoichiometry. So just practice lots. You know exactly what steps to do, and do this step next, and do that step next. Okay. And then again, no pressure. Just feel free to use whatever method, but just be open to both methods. I've done a few examples now with the formula method first, so I'm going to just go right to the unit analysis method for this example, and then I'll do the formula after, okay? I went ahead and wrote what was given and what's required. So we have an airbag. So what happens here is there's a substance, and some types of airbags, sodium azide. When a crash happens, this reaction occurs where it decomposes and produces sodium and then nitrogen gas. So the nitrogen inflates the airbag and so forth. So we know that a mass of 87.5 grams of nitrogen was formed. We need to figure out what mass of sodium azide was there initially in order for this to happen. Okay, and right away, every year I have a student say, NaN3, right? How is that possible? Sodium has a charge of 1 plus. How can it combine with nitrogen and make this compound and so forth? So this is like one of those exceptions, I guess. It's a compound where this nitrogen is actually not just nitrogen by itself, but it's like this triatomic compound with multiple bonds and so forth. So anyway, it's just a special compound, and that's why, yes, it's not following the ionic compound naming rules, okay? But again, all the nomenclature I've taught you this year, there's still a lot more out there to learn. But so I'm just teaching you the simple ionic compounds, but there are complex different ones out there like sodium azide, okay? All right, so we need to find the mass of sodium azide. So again, here is our plan. We're going to go through, we're going to, get to moles of nitrogen because we cannot compare mass. Remember, we cannot compare mass, but once we get it to moles, we can compare it and find the moles of sodium azide. And then once we find the moles, we can get to the mass. All right, so I'm going to use the unit analysis method, like I said, first. Okay, so when we're going through here, we are trying to find the mass of sodium azide. Okay, so I have this number to start with. So the mass of nitrogen. All right, so in that first step, so again, when we're island jumping, so remember you are trying to go from mass to moles, right? Mass to moles. So you need to use your molar mass. So, so we'll quickly do that over here. We're going to find the molar mass of nitrogen. So that's 2 times 14.01, so 28.02. Okay, and so when we go to put this in here, we don't want the grams to clash, so we're going to put the grams at the bottom. And so that makes it 28.02 at the bottom of nitrogen for 1 mole of nitrogen. Okay, all right. So then that step is done. So now we need to do the mole ratio. So again, we need molar mass here. Okay, that's how we jump to that island. We need the mole ratio here. And then again, we need the molar mass in this step here as well. Sorry, molar mass. Okay, so the mole ratio now, so remember the one that you are not trying to find, the one that's already given to you goes at the bottom, okay, because we're trying to cancel out that nitrogen. So, and then the one we need to find goes at the top, so that's the sodium azide. Okay, so 1 mole of nitrogen, or sorry, no, we have 3 moles of nitrogen to 2 moles of sodium azide. All right, that step is done. Now the last step. We need the molar mass of sodium azide, so let's do that here really quick. Okay, so sodium brings 22.99, and Nitrogen brings 14.01 times 3. Right, so that's a total of 65.02 grams per mole. Okay, so that goes right here, 65.02 grams for the sodium azide divided by the 1 mole of sodium azide. Okay, all right, so the quick calculations that you needed to make were the molar masses of the two substances. But then from there, you just kind of flip the molar masses whichever way they need to go. And then this part here, the mole ratio, you just take it from the balanced chemical equation. And then again, remember the one that you know goes at the bottom, the one at the top is the one that you need to find. And then you always just double check, did I do everything right? Yes, I have everything in the right spot. All the units that I need cancel out, leaving the unit that I need to have at the end, grams of sodium azide. So let's go through and calculate this out. Okay, so multiply everything at the top, hit equals, then divide the bottom stuff. Okay, and then we get to a total of okay, so 135.36. Okay, and I'm going back to my question here, looking at, okay, 87.53 digits. So I want to round this to 3 digits here like that. All right, and I'll write my therefore statement after I do the formula method. Okay, so there's the unit analysis method first. Okay, so you're still using this box method to help remind you that you have to take 3 steps if you're going from mass to mass. Okay, so you have to go mass to moles, to the other moles, and then to the mass. Okay, so you needed the molar masses, you needed the mole ratio, and then you just go through and cancel everything out nicely and get to your answer. Okay, all right, so for people that like the formula method, so I'm just going to call this step 1, step 2, and step 3 here. Okay, all right, so step 1, we have the mass of nitrogen, but we need the amount of nitrogen. Okay, all right, so again, in order to do that, we need the formula, N equals mass over molar mass. Okay, and then we do the mole ratio here, and then here, in order to get to mass, we're going to go amount times the molar mass. Okay, so in order to get the amount of nitrogen, I'm going to take the mass divided by the molar mass. So the mass that I was given at the beginning was 87.5 grams, divided by the molar mass that I calculated here in that corner is 28.02 grams per mole. And I will get 3.1227, etc. moles. Okay, keep it in your calculator. All right, step 2, I need to find now the amount of sodium azide. Okay, all right, this is a trickier one here because we don't have a nice ratio that we can work with, so we just have to break it apart, get it down to 1 to something ratio. All right, so again, sodium is 3, sodium azide is 2. Okay, so we have to get it to a ratio that will work for us here. So we know nitrogen, so we're going to get that one down to 1. Okay, so if we do that, we're going to divide by 3. So this one becomes a 2 over 3. Okay, so that ends up being 0.67. Okay, all right, so in order to calculate the amount of sodium azide, we're going to multiply by 2 over 3. Okay, because remember we're going this way. So we're going to multiply by 2 over 3. So the amount from before, which was this number here, we're going to multiply that by 2 and then divide by 3. Okay, and then we end up with 2.0818, etc., okay, moles of sodium azide. All right, step 3, last step, we need to get to the mass of sodium azide. Okay, so in order to do that, we need this formula. So we're just going to take our amount and times it by our molar mass. So the amount was from the previous part here, 2.08. Okay, just take whatever was in your calculator and multiply by the molar mass, which was 6502 grams per mole. And we get 135 grams, just like the other method. Okay, and so now we can make our therefore statement. Okay, so therefore, what is it that we had to find? Well, we had to find the mass. And the mass of what? Mass of sodium azide is 135 grams. Okay, so now that you've seen it so many times, hopefully you're feeling confident with both methods. And hopefully you're seeing the advantage of the unit analysis method, a lot less writing, a lot less work, kind of, yeah, so this way you're not memorizing formulas and so forth, and you kind of go through and slash everything out. Otherwise, if the formula works for you because it just organizes things better in your mind, then yes, use it, okay? Hopefully this mole ratio step is, you're really confident with it since you've seen the other video, and then getting to mass, and then writing a therefore statement. All right, so please practice more of these though on your own. Check your answers, and then if you're good to go, try the checkpoint, okay? The next day's lesson, again, will leapfrog off of this lesson, so you have to make sure you understand it and are comfortable with this one, okay? All right, thank you.